Morning to all. This is Priyanka and my topic is diffusion currents. Outline of this topic is introduction, current in semiconductors, diffusion current density, total current density. Introduction. First of all, the definition of diffusion is the movement of particles in a solid from an area of high concentration to an area of low concentration, resulting in the uniform distribution of the substance. During diffusion, molecules move from an area of high concentration to an area of low concentration. They are said to move down a concentration gradient. The material that undergoes the transport is known as diffusant or permanent or penetrant. Diffusion of charge carriers. Current in semiconductors at T is not equals to 0. The free carriers are in constant random motion due to their thermal energy. The net motion in any particular direction is 0. Therefore, total current I is equals to 0. There are two principal mechanisms by which a charge moves in a particular direction, thus creating an electric current: drift and diffusion. There are two ways to produce currents: drift current and diffusion current. The mechanism for drift current is electric field, and the mechanism for diffusion current is concentration gradient. Drift current and diffusion current in a PN junction diode. Here in drift current is an electric current due to the motion of charge carriers under the influence of an external electric field. And diffusion current. Diffusion current is an electric current due to the diffusion of carriers leading to a change in carrier concentration. Now let us discuss about diffusion current. Diffusion current occurs because of the physical principle that over time particles undergoing random motion will show a movement from a region of high concentration to a region of low air concentration. See here from the three figures, see plane A. In plane A, the particles are moving randomly. So T is equals to 0, that equals to T naught. And plan A, the particles are moving freely and it is entering to second band. So T is equals to T1. And third figure, the particles are moving too freely and it is entered to other side also. So T is equals to T2. Now let us discuss about diffusion current density. Current density is directly proportional to the gradient of carrier concentration. See here, from JN is equals to QDN into dN by dx. JP is equals to minus QDP into dP by dx. Here, dN and dP are the diffusion constants for electrons and holes respectively. Diffusion current due to holes. Here, hole diffusion and hole current both are moves in same direction. So, Jp is equals to minus QdP into dP by dx, and the graph comes like this. Diffusion current due to electron. Here, electron diffusion and electron current both move in opposite in direction. If there is an electric field and concentration gradient in the x direction, the total current is the sum of the drift current and diffusion current. Therefore, Jn is equals to Q capital D suffix n into dn by dx. dn represents the diffusion proportionality constant and dn by dx represents the concentration gradient. Total current density. When both electric field, that is gradient of electric potential, and concentration gradient present, therefore then the total current density J suffix n is equals to Q mu n capital E plus Q d suffix n into dn by dx, and Jp is equals to Q mu suffix P capital E minus Qd suffix P dP by dx. Then the total current density J total is equals to Jn plus Jp. Thank you for your attention.